Okay, this is chapter 11, section 1, and it's on water resources. The objectives are going to be to describe the distribution of Earth's water resources, to explain why fresh water is one of Earth's limited resources, to describe the distribution of Earth's surface water, and finally to describe the relationship between groundwater and surface water in a watershed. Okay, so water is essential to life on Earth. As humans, we can live for a really long time, up to a month without food, but we really can't live very long without water, only about a few days. Um, there's two different types of water. We have fresh water, which is water that doesn't contain salt or only a very little amount of it, and then salt water, which is the water that we see in ocean that's going to have a much higher concentration of the dissolved salts. Um, and most human uses for water, like drinking and agriculture, you have to have fresh water, which is kind of intuitive to us. You can't go out and drink salt water, and you can't grow plants in salt water for similar reasons. Those being that our cells, eukaryotic cells, which our cells, humans, and plant cells are made of, can't grow in salt water. So they have to have fresh water that has a much lower concentration of salt. This is the water cycle. So the water cycle essentially describes why water is a renewable resource. So you can kind of start at any one point in the cycle, but let's start with water on the land, where as we all know, when it gets warm, the water is gonna the water at the surface is going to move around, and it's going to eventually get enough energy to where it evaporates into the atmosphere. The water in the atmosphere is going to eventually undergo a process called condensation, where that water goes from water vapor, the gas form of water, and turns into liquid water again, and collects in our clouds and forms precipitation. And then it's going to rain down back onto the earth, and it'll flow from areas high in the mountains to form your streams and your rivers, and then the whole process, the whole cycle begins again. And this is just repeating what I just said. Um, and obviously most of Earth's water is going to be in the ocean. So getting into just how exactly water is distributed, um, the majority, up to 71% of Earth's surface, is covered in water. And of that water, 97% of it's going to be the salt water in the oceans and seas. And of that fresh water, so of that 3% of water that is fresh water, about 77% of that, so three-fourths of the 3% is frozen water in the glaciers and polar ice caps. Now, as glaciers and polar ice caps have been melting, especially in recent years, that number is going to decrease. But still, the point is that most of our Earth's fresh water isn't usable by us. We can't access it readily. It's either frozen or it's somewhere where it's hard for us to get to. And this is just a graphic repeating what I just said and putting it into a graph form. And the fresh water that we're going to use is going to come primarily from lakes and rivers, and then also from a very narrow zone just beneath the Earth's surface, which is referring to what's known as groundwater. So surface water is going to be, really as the name is going to suggest, it's going to be bodies of fresh water. Salt water, ice, and snow. So anything that's on the surface of the earth. So like the ocean, a stream, a river, and then also some things that we maybe don't think of, like ice and snow, are also considered part of surface water. And where surface water is located is going to be critical in how human societies have developed it throughout history, which should make sense, right? Because if you need water for human survival, if you need water for agriculture, then it makes sense that people are going to settle around where the water's at, because where the water's at, that's going to be where the plants can grow, and where the plants can grow, that's going to be where the animals are at. And where the animals are at, that's where the people who hunt those animals are going to be at. So, meaning that most large cities today are going to depend on surface water for drinking, for growing crops, using that water to catch fish, and even to power industry through hydroelectric dams, where you will block off a portion of a river and use the movement of water through that dam to generate energy, and then also for transportation, so boats going down bodies of water. How a stream. So a stream is going to be something that forms as thinking back to the water cycle diagram I showed, where whenever you have precipitation coming down, you had the mountains in the background. And so as water flows down from mountains, as it goes from an area of high altitude to low, it's going to start forming into these streams. And then these streams are going to combine with other streams, and eventually they're going to form a larger river. So a river system is going to be this idea of all these networks of rivers and streams that come out of a river basin. So you can think of a river basin like you can think of like a sink. So think of a river basin as this container, this area of land that just collects a lot of water. And then think of the rivers and streams that come from that basin as like the drain. So the world's largest river system is going to be the Amazon River system, where these rivers are draining an area over in South America that's just about the size of Europe. Related to this idea of a river system is what's called the watershed. So the watershed is just referring to that total area of land that's being drained by a water system. So river systems just describing the basic idea of rivers draining an area of land, whereas watershed is talking specifically about how large is that area. And the amount of water that's going to enter a watershed is going to vary throughout the year. And that's going to have to do with the fact that just the weather changes. So you might have some melting snow. Think of a watershed maybe up north in the United States or over in Russia, where in the winter months you get a lot of snow that accumulates, and as that snow melts, it becomes liquid water, and that liquid water can then go into the streams and rivers and make them a lot bigger. In contrast, in the summer months where you maybe don't have quite as much rain, or other times of the year, depending on where you're at, where you don't have as much rain, that watershed's gonna decrease in area. And this is just a map of all the world's watersheds. So there's many different ones. The U.S., the biggest one is going to be the Mississippi. Around where we're at in Texas, you have the Rio Grande, and then the Colorado. And then over here in South America, you have the world's largest, which is the Amazon. And then up here, these ones up here in the north are what I was talking about, where the frozen snow and ice, where once that frozen snow and ice melts in the summer, that's where the water the watershed's gonna increase a lot in area because you're adding that much more water to the streams and rivers. So this is a really, really good graphic that's just gonna cover most everything in the coming slides. So I'm going to just walk through most everything in the coming slides just by explaining on this graphic. So just going through one at a time. This is the same picture that had the water cycle, where right here you have the condensation, where the water goes from water vapor to liquid water, and then it starts dumping down as precipitation. An aquifer is going to be a region, if you allow me to jump forward, it's going to be a body of rock or sediment that stores this groundwater. So it stores this groundwater within all of the spaces of this rock. So this whole thing right here, this whole layer is going to be the aquifer. Where you have the upper layer of the aquifer is going to be what's called porous rock. So porous means you have a lot of spaces. So if you just look at the spaces in these rocks versus compared to non-porous rock, excuse me, you have much more space for water to flow in and out compared to here where the water's not going to be able to flow as much. So the aquifer forms with the more porous rock up top, and then which is called the water table. The water table is the very, very top of the aquifer. It's right where the water table is going to be where the water meets the land. And then at the very bottom, what forms the very bottom of the aquifer is going to be the non-porous and impermeable rock. So think of this as almost like a container that holds water that's underneath the ground. And so whenever it rains up here in what's called a recharge zone, it's going to rain down. In the recharge zone is going to be areas of land that have a lot of this porous, impermeable rock so that you can recharge the aquifer, meaning that wherever you have more porous, impermeable rock, that allows more and more water to trickle down through the rocks and into the aquifer. Something that's important to note about recharge zones is that because water can flow through this rock so easily, if you have things like pollutants that can come from the land, that also can flow very easily, just like water, through this porous, impermeable rock and contaminate the groundwater inside the aquifer. Meaning that we want to be very, very careful about our large recharge zones for our aquifers and limiting what kind of pollutants are going to be in that area, because those pollutants are going to be that much more toxic to humans. So we have the groundwater, we have an aquifer, and the question is, how do we access that water? There's some areas where the aquifer is going to form a spring where that water reaches the surface, but in most areas where people live at, you don't have a spring, so you build something called a well. So a well is just this structure where you just drill into the ground until you reach the water table, until you reach the area where the groundwater meets the land, the very, very top of the aquifer. And then you can suck up the water and use it. It's important to note that the level of the aquifer can increase and decrease throughout time, meaning that you want to drill this well much deeper than where the water meets at. So say the water for this well that's working right here, say that all you need to do is get to maybe right here to get water. Well, you don't want to just drill right here, because if you use up all that water, then it's going to become a dry well like this one. So you're going to want to drill even further down into this lower area of the aquifer so that you kind of give yourself some extra water for whenever you use it all up. Okay, so I'll go ahead and move on and fill in some of the blanks on the other slides. Okay, I already talked about this. So areas where the water table is going to be really, really far below the Earth's surface, maybe hundreds of meters, that's going to be what makes something a desert. And the water table is going to have peaks and valleys in it. So areas where the water table is closer to the Earth, and then valleys where it's further down from the Earth, like a desert. And it's going to match the shape of the land above. So areas that have more elevation are going to be more similar, are going to have a higher water table than areas that have a lower elevation. And groundwater is going to flow from where you have that higher elevation to where you have the lower elevation, from the peak to the valley. So aquifers, so things like rock, sand, gravel, that's going to be your more porous material, the material that has more of those spaces where the water can accumulate. Another thing to note is that groundwater can dissolve rock formation, which is where you can get some underground lakes and underground caves that form, because you have certain minerals and stuff in the water that can break down the rocks. Just getting some vocabulary. You have porosity, which is just talking about basically how much of the volume of that rock is contains open spaces. So it's like you take a rock, and if you were to cut it open and you look inside that rock, how much of that rock has open spaces? Versus a really dense rock that doesn't have very many open spaces, you would say it has a low porosity. Whereas rock like gravel that has all this space in between each piece of gravel is going to be very porous or have a high porosity. And the more porous a rock is, the more water it can hold. And then there's permeability, which is related to porosity, but permeability is more referring to how easily that water can flow from each pore. So gravel has a high porosity and also has a high permeability, whereas you have materials like clay and granite that are going to be more impermeable to water, where they have a low porosity, so they can't store as much water, and a low permeability, where water can't flow very easily from one area to the next. So our most productive aquifers are going to be composed of materials like sand, limestone, and then your sand and gravel. Things that have very permeable materials and a high porosity. Okay. Talked about all of this here. This is really important where if you have things like, whenever we build buildings and parking lots, those act like impermeable layers because when it rains, that water is just going to run off. It won't be able to soak through the concrete parking lot into the aquifer below. So they're going to form an impermeable layer. So we need to be careful about where we build our parking lots because if it's in an area that's normally a recharge zone, then you may inhibit our ability to refill our aquifers. And it can take tens of thousands of years to just refill an aquifer through normal rain. Okay. Um, Kind of, so we dig wells so that we can get access to that groundwater and get, a reliable source of water. But we also use groundwater because as water goes from the surface through the ground, it gets filtered. So as it goes through that porous rock acts as like think of like a coffee filter or a water filter. I mean, it literally it clings and it brings out some of those pollutants and anything else in the water that would make it not desirable for us. So typically your groundwater is going to be more pure and healthy drinking water than your surface water. Okay, and then if you have a well that dries up, you're going to have to keep drilling that well deeper and deeper. And so that's just going to do it for this section.